The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar. Today, we will be recording the webinar, so you will receive an email within 24 hours with a link to the slides from today's webinar, as well as to a recording of the webinar. If you have any questions, please enter them in the questions panel on the GoToWebinar control panel, and we'll answer as many questions as we have time for at the end of today's presentation. With that, Ivan, I'll turn it over to you.
Hello, everyone. Thank you, Terry, for the introduction. Can everyone hear me, and do everyone see the slides?
Yes, please raise your hand in the GoToWebinar control panel if you can hear us and see the slides. Great, see hands going up. We're all set.
Oh, okay, well set. Then let's start. And hello, everyone again. My name is Ivan Rakov, and my topic today is how to migrate your data schema to Apache Ignite. A few words about myself. I work at GridGain Systems, and right now I'm leading data consistency dev team. I'm Apache Ignite committer, and today we'll talk about more like getting started with Ignite SQL guide. From my experience, I'll tell about some examples where Ignite SQL is good and applicable, and I'll also tell you what Ignite SQL is not capable of, and I'll share some experience about these cases. So our agenda today is we'll start from what is and what is not Ignite SQL good for, its pros and cons. We'll proceed to Ignite SQL typical success cases. I'll tell about some business cases where Ignite were used and went to production, and it works well for now. Then we'll move to how to cook Ignite SQL 4-step guide. I'll provide some guidance about how to start using Ignite SQL from scratch, needed steps to configure it, and to make it working well on your specific queries. Then we'll proceed to fine performance tuning of Ignite SQL. I'll share some hidden, and maybe not hidden flags and system properties that are needed to be used in most cases, in most common cases. And at last, I'll drop a few words about how to live with Ignite SQL in production in case you need to change your schema. I'll talk about schema evolution. So let's proceed to the point about what is Ignite SQL actually and what it is good or not good for. What is Ignite SQL? Ignite can be Ignite itself is not just about SQL, it's distributed system, but it also has opportunity to use data with SQL syntax, just like it's done in distributed SQL databases. And Ignite SQL is ANSI 99 compliant. It's horizontally scalable and fault tolerant. And regarding its architecture, Ignite SQL is tightly coupled with H2 database. Basically, a local instance of H2 is run on every node of Ignite cluster, and we delegate a lot of things to H2, like query parsing, query optimizing, and local query execution. And distributed logic, when you need to combine results from your local H2 instances, is written by us, it's custom, and based on Ignite MapReduce logic. And data itself is not stored in H2 storage, it is stored in Ignite durable memory, which allow you to use RAM of heap speed and optional disk durability with write-ahead login, checkpointing, and all guarantees that regular databases provide. And such guarantees are shared by Ignite durable memory, which is work on off heap but persists with disk storage. Ignite SQL is good for, first of all, providing SQL access for large data sets. If your data is not fitting well in one server, you can make a distributed database and access your data with it, and it will work fine in most cases. Ignite SQL is fault tolerant. That means if in your distributed system one node will crash, cluster will leave, and SQL will keep. Fault tolerance is provided by Ignite and its affinity function and its partition change, primary partition change mechanisms. Ignite allows you to distribute your data very easily. In some more regular databases, you have to shard your data between nodes manually in case you are running in distributed case. And in Ignite, there's affinity function, which automatically balances your keys and your data among partitions. So there's no need for manual sharding. You just rely on to affinity function and your data gets distributed between nodes automatically. And Ignite SQL is able to provide better query performance than single database server because all cluster nodes work on a query simultaneously. But it's not always true. We'll talk about it a bit later when it's not true. But it's often true when query fits well in single MapReduce cycle. And query fits in MapReduce cycle when data rows from different nodes don't interact with each other. In such case, we can perform subqueries locally and just aggregate results on the reducer node of MapReduce cycle, and then just return query result to the client. And let's be a bit honest about what Ignite SQL is not good for. Ignite SQL is not good for consistent processing. First of all, you need to know that Ignite SQL is not transactional. There's a multi-version concurrency control implementation in Ignite, but it has appeared in 2.7 and it's also in beta version. That means that if you will try to perform something where consistency is really needed, like transactions or money transfer, you won't be able to do it with the full guarantees with Ignite. Ignite is not good with ad hoc SQL. Under ad hoc SQL, I mean when you have already preset your data, you have already preset your schema, and suddenly your analyst wants to execute sudden complex SQL query that is needed for your business right now. Random queries, which is complex even more, is likely to run long or even cause out-of-memory error in case your Ignite distributed database is not prepared for your query. I'll talk about how to deal with such queries later. And Ignite SQL is not good for query optimization. Ignite relies on H2 database, which query optimizer is quite well, but it's unaware of distributed specifics. It will optimize your query like it will be executed locally, and if it, of course, will be not executed locally, and then optimizer may provide some unexpected results for you. And Ignite SQL is not good for thoughtless usage of blocking operators. By blocking operator, I mean part of your query which will force presence of your whole dataset on some node. Ignite SQL accumulates intermediate query results in RAM. That means that your group by, for example, or order by over not indexed field or large table without condition can cause out of memory, because the whole data result will be loaded in memory of one node. It will be accumulated in RAM, and memory you can run out of memory. So that are, I think, most important disadvantages of Ignite. But if you will prepare it well, I think with most of them you can deal with. So let's get back about where Ignite SQL is good from my perspective. I'll share some knowledge about successful use cases on which Ignite were used and run in production right now. First use case is when you want to separate side activities from your main SQL processing. Imagine that you already have classic database like Oracle or Postgre, or perhaps some CRM that you use for your critical business processing like user transactions or money transfer, where consistency is really needed. And also, aside from your main activities, you have side business activities. For example, you want to perform end of day or end of month clearing. You don't need to execute such queries often, but sometimes you need it and it's really critical for your business. Or for example, you perform some kind of application maintenance, like you have app and you want to upload some reports to these apps, and these reports may contain a bit outdated data, and consistency issues are not really critical for these reports. And such side activities can be really resource intensive to run at MainDB, and they may affect performance of your critical main operations like transactions and money transfer. Or another reason may be that running these side queries for side activities may be too expensive to run at MainDB. For example, if you want to achieve the same performance while your side activity is running, you may require buying additional instances of your database, which can be expensive. Or in case you use some CRM and you get billed for the number of your API calls, you need to pay extra money for the side activities, and perhaps you don't do it. So a solution for this case is just keep your main business activities and transactions where they are, and set up a CDC, which is change data capture between main database and Ignite SQL database. And you, as a next step, you will just tune Ignite SQL to work well on your specific analytical queries. And if you will tune it well, you will enjoy the performance. So the main processing is working still on your main and maybe expensive DB, and all data gets replicated to Ignite cluster, on which you perform less critical but still important queries, and they perform here efficiently. Next option, when you still need consistency and you want to do something with SQL, is combining Ignite JCache and SQL. Ignite JCache itself, transactions, it provides fully ACID and fully distributed transactions, which can be used for business critical processing in your application. And at the same page, Ignite JCache API is not convenient for complex queries. For example, you can't just simply and efficiently join your two Ignite caches, or you can perform a lookup in case you want to index some fields and perform inefficient lookups. In such case, solution is just accessing the same data both with JCache and SQL. Ignite provides an opportunity to load data with JCache API and access it with SQL and vice versa. And JCache is good for consistent modifications and for your main business processing, and SQL is good for complex queries where you need to use joins or perhaps indexes where consistency under load is not that critical. So with these cases, I think Ignite SQL is good, and I know some examples where it was used and it's running in production. So I think if you have a case like that, you may consider using it as well. Okay, if you are thinking about how to use Ignite SQL, I'll tell you how. I'll provide a 4-step guide, how to bootstrap your data into Ignite, and how to tune it, and how to tune the performance, and how to keep living with it. First step is, of course, loading your data into Ignite and creating your Ignite SQL schema. There are two straightforward ways to do that. First of all, there's JCache first way. In case your main application is written in Java and you work with Java classes and JCache API, you can just mark your data with annotations. You can put query SQL field annotation over fields that you want to be present in your SQL schema. And in case you want indexes, you can just specify index equal true parameter, and such fields will be indexed. It's as simple as that. Annotation syntax is quite rich. For example, you can specify groups, and in case two fields are in the same index group, that means only one index will be created over, only one complex index will be created over several fields. Second way to bootstrap your data schema is SQL first way. Ignite SQL supports creating table with DDL. It's data definition language, and additional parameters can be passed using with syntax, and such opportunities called For example, if you want to create table person and you want to work with person ID is key and person info as value in Java, you just create such table, specify key type and value type in the template. And now you have two ways to access your data. You may access it with SQL while selecting over person table, and you can access it with Java with JCache API using person ID and person info classes and corresponding cache. So step 2, if you want to start using SQL, is you have to prepare queries that should perform well on your cluster in advance. Let's consider such business case. Imagine that you have tables, orders and accounts and tariffs, like you are running some kind of trading systems. So accounts contains information about users, orders contains information if someone wants to buy something, and tariffs has additional information about billing. And you want to, for example, collect big quantity traders that use basic tariffs at the end of every business day in order to prepare premium account offerings. So in case you will write an SQL query for this operation, it will look like this. It will look like select over 3 tables using join, using var close, where you filter rows by quantity and by commission percent. Sounds good, but how to make Ignite SQL work on this query efficiently? And step 3 is, and from my perspective, it's the very main step in tuning Ignite SQL, is data collocation. When you need to perform join, you need to know that by default, distributed joins work only when join data is collocated. By collocated, I mean that data rows on which you perform join, for example, it's account with ID 7 and order with ID 7, they should reside on the same node. In case it's not true, you need to transfer data between one node and another during join, and it's called distributed joins on over non-collocated data. And you have to know that by default, distributed joins work only when join data is collocated. In case it's not true, you can specify a flag distributed joins equal true. And this parameter can be specified over as URL parameter of your JDBC connection or on Java level API, and you can specify this parameter at your own risk. That means when join will be performed, there will be additional movements between some nodes in order to accumulate joined rows somewhere. And at last, your join will work sooner or later, but execution time and memory consumption may grow significantly. So it can be as a last resort solution in case you have already collocated schema and suddenly your analyst decides to execute ad hoc query, but you will need result of this query and you can sacrifice your time. You can wait a lot and sacrifice performance of a cluster, but you still need that result no matter what. You can specify that flag, and sooner or later your join will be completed and you will gain results. But the most common pattern in executing distributed joins is collocating your data. And let's consider this data schema and think about how can we collocate data here. Looks like orders table and accounts table contains lots of data, and perhaps tariffs is smaller table because I don't think there can be as much tariffs as there are accounts. And it's a good solution to mark account ID with affinity key mapped annotation. You can do it just in your Java code, and if you have done it, orders table will be affined to partitions according to affinity function based on account ID field, and so will do account table. And that means if orders and accounts caches have the same number of partitions. Orders with account ID and accounts with the same account ID will reside on the same nodes. That means that marking account ID field with affinity key mapped annotation on both orders and accounts tables will make data of orders and accounts collocated by account ID field. That means if you will ever decide to join orders and accounts table by account ID field, such joins will be collocated. So all the joining will be performed on local nodes, and already joined results will be returned to reducer, which is efficient. But of course, it's not that easy, and our join is more complex. We also need to join accounts and tariff fields by tariff ID. And the problem is that we can't collocate all three tables at once. We either need to choose collocation by account ID or either need to choose collocation by tariff ID. And as per tariff table has less data, the solution here is to make tariff table replicated. By replicated, I mean that all data about tariffs will be present on every cluster node. And that means that every join with tariff table will be collocated because every row on which we need to join is present on every data node. And it's not that costly because tariff has not that much data. So it's quite a common pattern. Collocate what you can collocate, and if you can't collocate something, you can just make it replicated. And choose bigger tables to be collocated and choose smaller tables to be replicated. That's the solution. So next is step 4 is performance tuning. Of course, when we are talking about performance, we are talking about indexes. Ignite supports only ordered B+3 indexes, and indexing account ID and tariff ID fields would subjoin because it would be much more easy to find according data rows. And what you need to know about indexing performance is such parameter as inline size. Inline size have the following behavior. It inlines results of it aligns values of indexed fields right into B+3. By default, B+3 index only has links to data rows, and when you perform indexed operation, you need to dereference data row and read actual values from there. In case you use inlining, you will not need to do extra hop. You will not need to load extra page from data row with data row from disk, and your index will work faster. So for example, with this syntax, create index and specify an inline size 60, you mean that every pairs of country and city which size is less than 60 will be inlined right into B+3, and lookup on these fields will be efficient. So, and as a next step, when everything your schema and your indexes are set, you can proceed to fine-tuning. It may look like hacking, but Ignite SQL provides various parameters to match your specific query and to make your specific query work well. And about most common of them, I will tell you right now. So let's proceed to fine-tuning of Ignite SQL performance. First parameter that I want to talk about is query parallelism. By default, every query is executed with one thread per node. It's bound to one thread due to concurrency issues, but even though it can be changed with the special field query parallelism in cache configuration. Such field can't be changed in runtime, so you have to think about your parallelism and performance in advance. And it's implemented this way because it causes storage place overhead, because when you specify query parallelism for example, every B+3 will be present in 4 instances. So your query will be split on nodes, and each subquery will run on its own B+3, which of course will be faster, but you need to sacrifice some storage place for that. Next option is lazy flag. By default, the whole query result is composed in memory on reducer nodes in Ignite SQL, but this can be changed with if you will use set lazy. It also can be specified as URL parameter of JDBC connection or in Java API. And using lazy mode for cases when only part of the large result is needed is good, because from select asterisk from very big table without very close, only first batch of data will be loaded to your client, and if you will continue gaining data with JDBC, the next batch of data will be loaded, and so on. It's a good pattern to use setLazy, but it of course will not work every time, because setLazy will not help you for blocking operators like aggregation functions like group by or executing order by over not indexed field. Because you will still need to accumulate all data on reducer in order to perform aggregation or to perform sorting. Next option is set collocated flag, and I'll tell you what it's needed for. By default, aggregation functions are considered as non-collocated. That means if you will write where, for example, every data row on which your where clause can be applicable will be loaded to reducer node, and only on one reducer node your Ignite SQL cluster will perform aggregation. And when all results will be aggregated on one node, your client will receive result. It's not the most efficient way, because in case you are sure that you perform aggregation on collocated field, you can use set collocated. In such case, collocation will be performed on map nodes, and which is of course more scalable. Every mapper node will compose its own aggregated results first, and then only aggregated results, but not all data rows, will be transferred to reducer node, and from reducer node will be returned to your client. It's much more efficient, but in case you are not sure that your data are not collected, don't use set collocated flag, because it will cause unpredictable query results. Next useful but a bit painful option to use is Ignite SQL merge table max size. It's configured with a system property, and you should configure it in case you expect big aggregation result. By default, aggregation functions like group by are supported for up to 10,000 various keys. And if you expect that aggregation on larger number of keys is possible, for example, you perform group by over key where bigger amount than 10,000 is present in your table, such group by query will just fail, and you will not be able to get your results. You will need to use another queries. And in case you are sure in advance that you will need to perform operations on bigger amount of keys, you can just override aforementioned system property, and unfortunately that can be changed in runtime. So you also have to think in advance how big your aggregated reports will be. And last but not least option is using forced table join order. I'll remind you that it's not a good idea to fully rely on Ignite Query Optimizer, because it doesn't understand distributed specifics well. And also only nested loop joins are fully supported in Ignite. Ignite also has hash joins, but it has it in experimental mode. And it's a good idea to use explain plan on your queries. And in case you are planning big join and you have executed explain plan and you are not satisfied on join order, you can add flag set and force join order true. And in such case, tables will be joined in the order of mention in your SQL query. The command pattern here is to place smaller table here first, because in such case nested loops will work in a bit more efficient way. So of course there are much more advices about performance which you can find in documentation, but now we'll proceed to schema evolution in Ignite SQL. Here I need to mention critical things. That first of all, you can add or remove columns from the table. You can use alter table add column, alter table dropped column, but you need to know here that storage data will not be affected by such statement. What will be affected is only select asterisk statements. So if you want to save some space in your database, remove some columns, save it for another information, drop column will not help you here because you will execute it. Column will disappear from your schema, but data will be still present in data storage. First of all, it's implemented this way due to compliance with binary objects. Please remember that you still will be able to work with this data with JCache API with your old classes. And very main, from my perspective, thing to know here is that changing of column type is not supported here, not supported in Ignite. If you want to change type of your column, please remove column and add another column with different name and different type. Unfortunately, Ignite binary objects storage schema doesn't support changing type of your field. And if we will try to change type of a column and even portion of all data will be present in cluster, you will gain something like binary object exception when you will try to access that table. Also, what you need to know about schema evolution is that when you use annotations in your Java code in order to specify your schema, such annotations will be applied only on first usage of these classes. So when you will load first instance of your class into JCache, table will be created according to your annotations. But later, if you want to evolve your schema, you will need to use DDL and alter table statements. Adding annotations in code will not change anything, but it's still a good pattern to keep your annotations in code aligned with your actual SQL schema, because if you want to bootstrap your data from scratch, you will not need to hastily change your annotations. In case they are already kept in order, you will just start putting data into Ignite and your schema will be actual. So let's summarize what have we discussed. Ignite SQL will not serve you like as good as universal as something like Oracle or Postgre, but distributed. But in case you know what queries should perform well on your cluster, and if you plan your queries and configure collocation in advance, it will bring you decent performance, and your SQL engine will be empowered by other Ignite features. Because if you have loaded your data into Ignite via SQL, you can still access it with JCache, you can perform computes, and so on. So that's it. Thank you all for your attention. And now I'm ready to answer your questions. Below are links to my email, to user list where you can ask any question about SQL, and to SQL documentation from GridGain site. Thank you.
Okay, thank you, Ivan. I have a few questions. Again, if you do have a question, please put it in the questions panel in the GoToWebinar controls. First question is, how do you connect to SQL that is running in Ignite? Is it just like normal client JDBC tools?
Well, in order to connect to a SQL cluster, first of all, you can just use regular JDBC. You will need to configure Ignite JDBC driver, of course, but in case you have configured it, you can just use regular JDBC interfaces in your Java application. It's not the only way, of course. You can also use ODBC, and there's also an option to connect with to execute SQL statements from Java API. On Ignite Cache, there's method query, which gets query SQL fields and returns you a result set.
Okay. Next question. Can we have a different data? Can we have a different date format for the database? Or can we have different date formats for the database? Sorry.
Yeah, from what I know, Ignite supports several types of date and time formats. You can, for more information, please check documentation. There's and I remember that there's a list of supported types that Ignite SQL supports, so you can find necessary information about date and times here.
Okay, next question. Can the data feeds used for data loads have different delimiters other than commas?
Different delimiters. Okay, you mean data loading with data loading with something like scripts with SQL statements? Yeah, I can't answer that question, but I think if you will. It's that you can ask on user list.
Okay. Can you use Ignite as an ad hoc reporting data storage layer?
First of all, if you will need ad hoc reports, Ignite SQL isn't built for it, and ad hoc SQL is not the best part of Ignite. But in case you are sure what ad hoc queries your ad hoc queries nearly can be, and on which tables you will need to perform joins, you can configure your collocation. So most of your ad hoc queries will work, and such queries that will not work, you can specify distributed joins for them, and it may work. So the answer isn't yes or no. The answer it depends on how different your ad hoc queries will be.
Okay. Next question. Can you compare JCache use case, the JCache use case to using the Scala library for Ignite RDDs?
Not familiar with Scala libraries, but I guess Scala allows you to use the same API because you can just use you can still execute methods from Java classes from Scala. So I think the API is quite the same. So, but perhaps I didn't understood the question correctly. But from an O, of course.
Okay, sounds like a good question for the user list.
Sure.
What databases are easy to migrate, and what databases are hard to migrate, and how many use cases do you have?
From what I know, we have various use cases, like perhaps tens or maybe 100 of production usage of Ignite. And regarding migrating from database, it's not depends that much on database like it depends on difference of your SQL queries, because executing some queries are easy to execute in distributed SQL and some don't. If you are interested in syntax, you can compare syntax of your database to syntax of H2 database, because we delegate query parsing to H2.
Okay, and are asset transactions supported with Scala Ignite RDDs?
Transactions are not supported in SQL so far in any way, so there is no way to execute transactions with SQL. But if you're able to access JCache from Scala, so I guess yes, you can use transactions and you can change your data consistently.
Okay. When I need to scale my cluster or add more nodes, what should I do?
So the most common pattern here is just add more nodes in case you're using in-memory solution. And in case you're using persistent solution, you need to add nodes to your cluster and execute set baseline topology method. So there's such thing as baseline. It's a topic for a separate talk. But what is important here that only after changing baseline, your data will actually migrate to the new nodes. And when data is in progress of migration, your cluster will work, your queries will work, because Ignite supports rebalancing under load. So you will access those partitions that has full amount of data while rebalancing is in progress. And when it will be completed, you will just access all of your partitions.
Okay, and next question is it possible to access SQL from the Java API?
Sure, it's possible. You can do that with Ignite Cache class, and you can do a query method, and it allows you to put your query in string representation here and get the result. And it may confuse you because your query may interfere with different caches, and query method is method of one specific Ignite cache, but it's still okay. With every Ignite cache, you can access all your caches in system with SQL.
Okay, very good. That's all the questions for today. If you watch for your email inbox, you will receive a link to the recording of today's webinar, and we'll also make the slides available from today's webinar. And please watch for upcoming webinars. You can view them on the resources/webinars page on the GridGain.com website. Thank you, Ivan, and thanks everyone. Have a good day.
Thank you.